Hello and welcome to the MAML Manual. I'm Sebastian.
And I'm Iris.
And today we'll be covering Meet number 1, topic number 1, Arithmetic with star operations. Without further ado, let's jump right into it. And here is our first problem. For your reference, these are all from previous competitions, so if you want to look at this on your own, this will give you the year and the question number. So this particular problem in Arithmetic with star operations is from 2010 and it's question number 1. Okay. Let a star b equal the absolute value of a minus the absolute value of b. If x star negative 4 is equal to 2, how many values could x have? Notice how, in this question, it's asking you how many values x could have, and it's not actually asking you to solve for x. I'm going to solve for x anyway, just to show you the process of solving this problem, but you could theoretically just logic this out and think about it. But just to make sure that we're getting to the right answer, let's solve for x in its entirety. So let's set this up. X star negative 4. Let's plug this into the star operation equation that they defined above. So x star negative 4 would equal the absolute value of x minus the absolute value of negative 4, which is just 4, so we can put 4 here. And we have this expression now. And that's a lot of absolute values, but don't worry, this will simplify. So plugging it into that, we get this. And they told us up here that x star negative 4 is equal to 2. So we can say that this expression here is equal to 2. So we have the absolute value of x minus 4 is equal to 2. Now, because there are absolute value bars on the outside here, we can look on the inside and say, okay, well this, the absolute value of x, minus 4, can either be 2 or negative 2. Because if this is 2, then the absolute value of 2 is 2. But if it's negative 2, the absolute value of negative 2 is also 2. So this expression here can either equal 2 or negative 2. So let's write that over here. The absolute value of x minus 4 is equal to 2, or the absolute value of x minus 4 is equal to negative 2. Now all we have to do is add 4 to both sides. Over here we get the absolute value of x is equal to 6. And over here we get the absolute value of x is equal to 2. Now, because this is an absolute value, we realize that x can either be 6 or negative 6. So we say x is equal to plus or minus 6. And over here, x is equal to plus or minus 2. Those are all the possible values for x, and again, returning to what the question is actually asking, it's not asking us to solve for x, it's just asking us to solve for how many values x could have. And we can see here, plus or minus 6 and plus or minus 2, and so our answer is that x can have 4 values. Let's move on to the next question. Here we have a classic star operation problem where they give us not one but 2 different definitions of operations, and then they give us this expression to solve with purely numbers. So we have numbers and we are plugging them in to equations that they give us. So let's do that. What I notice is a star b, I'm just going to simplify it a little bit. They have a common factor of 2, so I'll just do a star b is equal to 2 parentheses a minus b. I'll just factor out that 2 for ease. And same thing over here, the 3 is common, so I will do c triangle d is equal to 3 c plus d. Factor out the common factor. Now we have to determine this value, and in star operation problems, even though they're different operations than our normal PEMDAS, we still have parentheses, so we will do the parentheses first. So let's start with 3 star 2. 3 star 2, and up here we have said is equal to 2 times a minus b, which is 2 times 3 minus 2, which is equal to 2 times 1, which is just 2. Okay, so now let's do the right side of the equation. So we have 2 star 3, and we're still using this equation over here. We get 2 times a minus b, and a minus b in this case is 2 and 3, so it's 2 times 2 minus 3. 2 minus 3 is negative 1, and 2 times negative 1 is equal to negative 2. So this side, the left side of the equation, we've got 2. The right side of the equation, we've got negative 2. Now we combine those together and we apply the triangle operator to them. So we have 2 triangle -2 is equal to, and we have it up here, 3 times c plus d, which in this case would be 2 plus -2. Notice this, 2 plus -2, those just cancel out to 0. So really, our final expression is 3 times 0, which is just 0. So all of this work that we did all results in a 0. So that is our final answer. All right, here's our third problem for this video. This is interesting in that the operation they're defining is not on 2 variables, a and b, it's just on 1 variable, x. So let x double bar, it's like an equal sign, but it's not, so I'll just call it double bar. Let x double bar equal to x squared minus 1. Find all possible values of a if a double bar is equal to 143. Based on their definition here, a double bar is equal to a squared minus 1. At the same time, they tell us that a double bar is equal to 143. Therefore, if a double bar equals both of those things, then we can say that a squared minus 1 is equal to 143. Add the 1 to both sides, a squared is equal to 144. And of course, the square root both sides, you get 12. But notice that a can be 12 or -12. Because when you square -12, you're going to end up with 144. So we're going to have to be wary of that and say that a is equal to plus or minus 12. And this would be an acceptable way to write it. You could also write it as a equals 12 or a equals -12. That would be an acceptable way to write it. Or you could just list 12, -12, and they would also accept that, so long as you don't put them in parentheses, because that would be an ordered pair. Perfect. Let's move on to the next question. This one is a mouthful. A man sold 1/3 of his crop of bales of hay to his neighbor. He then sold 1/5 of what was left to a second neighbor. He finally sold 1/7 of what was then left to a third neighbor, leaving him with 336 bales of hay to feed his horses for the winter. How many bales of hay were in his total crop? So of course they give you information that isn't really relevant to solving the problem, but that's all right, it's entertaining at the very least. So let's work backwards. So we're trying to find out where he started, but we're given where he ended. We're not going to be able to make that leap unless we work backwards incrementally. So let's do that. So it says here, he finally sold 1/7 of what was then left to a third neighbor, leaving him with 336 bales of hay. This is important. If he sold 1/7 and is left with 336, that means 336 must be 6/7 of whatever he had before. So we can write that as an equation. 336 is equal to 6/7 of whatever he had before. If we're trying to find whatever he had before, in this case x, multiply both sides by 7/6. The 7/6 here will cancel, and we do 336 times 7/6. We divide 336 by 6, and we get 56. And then we multiply 56 by 7, and we get 392. So, we have found that x is equal to 392, but of course we're not done with the problem yet. We have to work a step backward. He then sold 1/5 of what was left to a second neighbor. So we know that 392 must be 4/5 of what he had originally. If he sold 1/5 and is left with 392, then this represents 4/5 of what he had originally. So we can write 392 is equal to 4/5 y. We'll use another variable. And to find y, we multiply both sides by 5/4 in this case. We get 392 times 5/4 to get y. So we divide 392 by 4. And notice that 400 divided by 4 is 100. So we go down by 8, which means we go down by 2 in our answer. So 100 minus 2 is 98. So 392 divided by 4 is 98. Multiply that by 5 and we get 490. So we've solved that y is equal to 490. And we are left with our final step of the equation, or of the word problem. A man sold 1/3 of his crop of bales of hay to his neighbor. This is what remained after he sold 1/3. Therefore, 490 must be 2/3 of what he had originally. I'm sure you're getting the logic at this point. So we can say that 490 is equal to 2/3 of what he had originally, in this case, z. To get rid of that 2/3, multiply both sides by 3/2, and we get 490 times 3/2. 490 divided by 2 is 245. I'll write that down, 245. And then 245 times 3 would be 735. 735. So our answer to this problem is 735. And no, you do not need units, but if you wanted to entertain yourself and you had, I don't know, 30 seconds to spare in the competition, you could write 735 bales of hay if you wanted to. Also, I've erased my work at this point, but notice that this problem isn't really a star operation problem. There's no equation here that the MAML writers are defining. They can do that in an arithmetic section, of which there is one every single meet, and it's always the first topic. They can throw at you arithmetic questions that don't relate to the main topic of that meet. Or in this case, it's arithmetic with star operations, but a star operation does not need to show up in the question. There will be at least one, most likely two, but they can also give you just a random arithmetic question. So that's why it's good to be well-versed in these sorts of things, and it just takes practice, which we're doing now. All right, let's move on to the next question. Okay, the price of a can of Pepsi is 50 cents plus half its price. What would 2,000 cans of Pepsi cost in dollars? Again, not really a star operation problem. They're not defining one and you're not plugging numbers in, but it's still an arithmetic question and we can solve it. So the price of a can of Pepsi. Let's define that. Let's say P is equal to price of can of Pepsi. Wonderful. Now, all we need to do is convert this word problem into an equation. The price of a can of Pepsi, P, is equal to 50 cents plus half its price. Well, its price is P, so half its price is 1/2 P. All we have to do is subtract 1/2 P from both sides. We get 1/2 P is equal to 50 cents, and if half of the price is 50 cents, then the full price must be 100 cents or $1. Now it's asking me, what would 2,000 cans of Pepsi cost in dollars? Well, if the price of a Pepsi can is $1, then the final price would be $2,000. Now, if you're buying 2,000 cans of Pepsi, you're probably ordering in bulk, and I would hope you would get a discount. But just solving for this, you get $2,000 as your answer. Let's move on to the next problem. Wonderful. This is our 6th question of the video. If P star T is equal to this mess, find 30.00 star 24.17. If you were to look at this expression and you didn't know what these symbols, which are like brackets without the top, if you didn't know what those symbols were, you would be very confused. Luckily, the problem does tell you. Note that x with these brackets is the greatest integer less than or equal to x. In mathematics, we call this the floor function or the greatest integer function. Those two are interchangeable. It's either the floor or the greatest integer. I'm going to use floor just because I like saying floor better and it's shorter, but you can choose what you want. Okay, let's solve this problem. First, I will do P minus T. 30.00 minus 24.17. Well, if we take 0.17 away, we're going to need 0.83 to fill that up to get a whole 0.00. So I know that our answer is going to end in 0.83. And then I know that 30 minus 24 would be 6, but we're doing 30 minus 24.17, so it will be a little bit less than 6, so it's going to be 5 here. So that minus that is equal to 5.83. Now, it's the same thing with the floor there. Okay, so p minus t, we know is 5.83, but now we need to apply the floor function to 5.83. Well, the floor function is just the greatest integer less than or equal to x, and in this case, it would be 5. So 5 is the greatest integer less than or equal to x, so floor of 5.83 is 5. And I find that floor makes more sense because we're going, it's on the ground, we're going down, versus ceiling, you would be going up. If you say it's the greatest integer function, it might make you think that we need to go up because it's greater than, so I just am using floor to avoid confusion here as well. 5.83, the floor of 5.83 is equal to 5. Perfect. Now, if we do 5.83 minus 5, we would end up getting 0.83. Now we have 0.83 divided by 0.25. Because 0.25 is 1 over 4, dividing by 1 over 4 is the same thing as multiplying by 4. So we have here 0.83 times 4, which would equal 3.32. Okay. We have 3.32, and now the final step we have is to take the floor of 3.32. And of course, the floor of 3.32 would be 3. So our final answer to this one is 3. All right, we have reached the final 3 questions in this video. They are all 5-pointers, the third question of that year. So they're going to be a little more difficult, but we'll tackle them together. If a star b is equal to a squared plus b, and c star d is equal to d star c, find d in terms of c, where both of the variables are greater than 0. This is a weird one, but because it's not telling you to plug in any values to the equation they define. It's not telling you to plug in 2 or plug in 4. Instead, we're plugging in variables. So let's just see how this goes. Let's do that. So c star d is equal to c squared plus d. D star c is equal to d squared plus c. Up here in the problem, it says that c star d is equal to d star c. So we can then conclude that c squared plus d is equal to d squared plus c. Now my first thought is, okay, well let's get all the c's together and let's get all the d's together. So we get c squared minus c is equal to d squared minus d. We can factor out a c and a d. We get c times c minus 1 is equal to d times d minus 1. And when I see this, I say, okay, well, aren't c and d the same thing? If we plug in 2, we get 2 times 1. If we plug in 2, we get 2 times 1. So we get 2 equals 2, which is a true statement. If you look at this, you say, well, c has to equal d in all scenarios. However, it's not expressly worded in the question, but given that c and d are different variables, that's not what MAML is looking for. MAML is not looking for you to say c equals d. That would be too easy, and it's also it's uncharacteristically easy for a 5-pointer question. So when you get to this point, you have to say to yourself, there has to be more here that I'm not thinking of. And that more, in this particular case, comes in the form of dots, or the difference of 2 squares. So, instead of lumping the c's and lumping the d's together, we can lump the squares together and lump the non-squares on the other side. So, subtract d squared, we get c squared minus d squared, and then if we move this d to the other side, we get c minus d. Now, because this is the difference of 2 squares, we can factor it out to c plus d times c minus d is equal to c minus d. And if we divide both sides by c minus d, by that factor, so here we get c plus d is equal to 1. Or, expressing d in terms of c, we find that d is equal to 1 minus c. And that is our final answer. All right, next question. So, this is similar to the last one in that they're not giving us any numbers, to plug in. They are just giving us, they're defining star operations, and then they're giving us letters to plug into the equation and to simplify those, or to in this case, factor them. So let's do that. So if x star y is equal to x squared minus y squared, and x hashtag y is equal to y squared minus x squared, find that in factored form. So I do notice that both of these are the difference of two squares, so I'm going to keep that in mind. Let's do a star b first. A star b would be a squared minus b squared, or we could write it as a plus b times a minus b. I'm not going to do that yet, just because I don't know where this problem is leading, so I'll leave it there for now. And then over here we have a star c, and that'll just get us a squared minus c squared. Perfect. Now, the whole thing, we are applying the hashtag operation to a squared minus b squared and a squared minus c squared. So what we end up getting is a squared minus b squared hashtag a squared minus c squared. So here I notice that the difference of two squares might actually benefit us, because on both sides of this equation we have an a squared term, and in a difference of two squares we subtract the terms in one of the factors. So those a squareds would actually end up canceling. So I think that this would be a good time to use our difference of two squares knowledge. So we can redefine x hashtag y as being not y squared minus x squared, but y plus x times y minus x. So over here, let's do that. So starting with that first factor, y plus x, a squared minus c squared plus a squared minus b squared, we end up getting 2a squareds minus b squared minus c squared. That is one of our factors. Now, for the other factor, y minus x, we have a squared minus c squared minus a squared plus b squared, because we need to invert the signs of both of those terms in that expression. That a squared and that negative a squared cancel, so we are left with a positive b squared and a negative c squared. And notice that that is also a difference of two squares. So b squared minus c squared can be simplified to b plus c times b minus c. And now we have three factors that, once we write them all together, will be the factored form of this expression. So we get 2a squared minus b squared minus c squared as one factor. We have b plus c as another factor, and b minus c as a third factor. So this entire expression here is our final answer. And for our final question of arithmetic with star operations, at least in this video, we actually don't have a star operations problem. The irony. The sum of three numbers is 98. The first number is 2/3 of the second, and the second number is 5/8 of the third. What is the second number? So it's another word problem like the bales of hay problem, but it's not in a ridiculous context, it's in a mathematical context. So the sum of three numbers is 98. I'm going to call those three numbers x, y, and z. You could call them anything you want. You could call them a, b, c, alpha, beta, gamma, what have you. Okay. Now, the question is telling us that the sum is 98. The first number x is equal to 2/3 of the second number y, and the second number y is equal to 5/8 of the third number z. What is the second number? Now, to be able to solve this equation, we are going to have to get everything in terms of one variable, because we only have one equation. And if we only have one equation, we need only one variable to solve it. If we had two variables, there would be an infinite number of solutions. So let's get this all to one variable. And to do that, I'm going to express everything in terms of y. And the reason why I'm doing that is because y is the second number, and the question is asking for the second number. And so I'm going to write everything in terms of y so that when I get the answer, everything, it's already solved. We don't have to do any other steps. Okay, so here we have a y, so we don't need to do anything with this y. Here, we see that x is equal to 2/3 y. So we can replace x with 2/3 y. And now we need to replace z. Here we have that y is equal to 5/8 z, but I want z to be by itself. So I multiply both sides by 8/5 and get z is equal to 8/5 y. Now I can replace z and I get 8/5 y equals 98. So now we have a single variable expression that I am able to solve. 2/3 y plus 8/5 y is equal to 98. Now all I have to do is worry about adding these coefficients. And to do that, I'm going to have to find a like term. The like term is going to be 15 in this case. So the 2/3 will transform into 10/15. The 1 will turn into 15/15. And the 8/5 will transform into 24/15. Add those up, the 15 remains constant on the denominator, and the tops of the fractions. 10 plus 15 is 25. 25 plus 24 is equal to 49. So we end up getting 49/15. And that's the sum of the coefficients. So we get 49/15y is equal to 98. Because we want y by itself, we multiply both sides by 15/49. So if we do 98 times 15/49, you might be tempted to do 98 times 15 and then divide that by 49, but notice that 98 divided by 49 is simply 2. So we can cancel that out, treat that as 2, and then all we have to do is 2 times 15, and we get our final answer, which is 30. So that problem works out conveniently, and if you want to confirm that you got the right answer, you are more than welcome to do so. X would be 2/3 of y. 2/3 of 30 is 20. So we get 20 plus 30. And then we get y is equal to 5/8 of z. So 30 is 5/8 of that third number. Or as we said, that third number is 8/5 y. And 8/5 y, 30 divided by 5 is 6. 6 times 8 is 48. So we would find that our third number is 48. And when you do 20 plus 30, you get 50. 50 plus 48, you get 98. So this satisfies everything in the problem. We get that our second number is 30. This was our video on arithmetic with star operations, the first topic in meet number 1.
Thank you for watching.
I'm Sebastian.
And I'm Iris.
And we're the MAML Manual.